Right, so this is the Year 10 exam, question 4 on circuits. So question 4, part A, we're trying to calculate the potential difference across the 3 cells that are joined in series. So that's these 3 cells here. Okay, each cell has a potential difference of 1.5 volts. So it's simply 3 times by 1.5, which equals 4.5 volts. Remember the unit. What will be the reading on the voltmeter labeled V3? Okay, so this one here. So we have 2 lamps that are in series with each other. That means they're going to share the potential difference. Okay, they're going to use half the energy each that's being provided by these 3 cells. That is the 4.5 volts. Therefore, because the lamps have got the same resistance each, they will have half of the voltage each, so they are each going to get 4.5 divided by 2, which is 2.25 volts. Again, remember the units. Which voltmeter, V1, V2 or V3 will give the highest reading? Well, let's have a look. We've got 1.5 volts for that cell, 3 volts for this cell, and 4.5 volts for this cell. We've said that V3 is going to be 2.25. We know that for this first circuit over here, V1 is going to be 1.5 because that lamp is going to take all of the voltage available from that cell. Okay, and the same is going to be true for V2. It's going to take all of the voltage available. That lamp is going to use all the voltage available to it from that cell. Therefore, V2 has 3 volts. So we've got V1, 1.5, V2, 3, V3, 2.25. So it is V2, okay, which was equal to 3 volts. That is your answer. Right, moving on. So the diagram shows our circuit. Again, we've got 2 resistors which are sharing some voltage provided by this cell, but we don't know the voltage of the cell, and actually it doesn't matter at all. Okay, it asks us first of all to calculate the total resistance of the 2 resistors. Okay, resistors in series is nice and easy. All we need to do, okay, is just say that the total resistance is the sum of the 2 resistances, therefore 30, and again, remember your unit or you will lose the marks. Okay, so 30 ohms. You can write ohms, that isn't a problem. Calculate the reading on the voltmeter. Okay, well here, what we need to do, very simply, is note that to find that voltage, okay, so the voltage across that component, I just need to know that V equals I times R, current times resistance, where I is the current that flows through the component, 0.4 amps, and R is the resistance of the component, 20 ohms. Okay, a lot of people were finding the total voltage, which was 0.4 times the total resistance, 30. Here we just want the voltage across the 20 ohm resistor, so it's 0.4 amps, the current flowing through it, 20 ohms, the resistance of the 20 ohm resistor, and that gives us 8 volts. Okay, again, remembering the unit, there is a mark for it. Another way of doing this would be to work out the total voltage, which is I times by the total resistance. So that would be 0.4 times 30, giving you 12 volts. Okay, and then use a potential divider arrangement. So we know that these things are going to share the voltage in ratio to their resistances, in the ratio of their resistances, and hence we know that we're going to have, so the voltage that's shown across here is going to be, what is it? It's going to be 20 over 30. Okay, so it's 20 ohms out of the total 30 times by that 12, so 2/3 of it, which is the 8 volts anyway. However, this method is far, far easier. I would stick to that.